And we're back. We solved linear equations in the previous video, so now we got to jump into solving linear inequalities in one variable for this video. Good news is the steps are essentially the same when you're solving linear inequalities in one variable as they are with solving linear equations in one variable. A lot of the same techniques as far as eliminating fractions and decimals, simplifying each side, using addition property of equality, using multiplication property of equality. But you are dealing with inequalities, so there are some things you have to be aware of as you're going through those steps or going through those processes. First of all, it is an inequality, so the solution's not going to be just like one number, like x equals 2. Rather, it's going to be an interval, because you're going to have like x is less than 2, or x is greater than or equal to 2, something like that. Also, if you're carrying out the multiplication property of equality, and you find that you have to multiply or divide both sides of the inequality by a negative number, then you have to make sure you flip or reverse the inequality sign. You have to keep the inequality working true because of that. So those are two key things that are different than equations, but as far as the actual like what step do I do next kind of thing, well, that's very similar to the equations. So, and then like I mentioned a minute ago, the solutions are going to be intervals, and in this course you're going to write those in something called interval notation. I already started using some interval notation previously, but I'll make sure to show you again with some examples in this section. The intervals are written always from smaller to larger. That's kind of a natural way to write things. Smaller value on the left, larger value on the right. It follows like a number line. Number lines get smaller going left, larger going right. And the interval will have your extreme endpoints. So it'll have your leftmost value, your rightmost value, with a comma in between. So it's going to look kind of like an ordered pair, but the context of it will tell you it's an interval. And then you'll either use parentheses or brackets around it. If you have a less than or greater than sign, or if you have negative infinity, greater than, or positive infinity, if you have those kinds of things, you'll always use parentheses. And if you have less than or equal to, or greater than or equal to, then you'll use brackets. Because the brackets are saying that the endpoints are included. And so when you have that equals to, then you have to include the endpoints. And the parentheses are saying, well, don't include the endpoints. So if it's just plain old less than or greater than, then you don't include the endpoints, because the endpoints are what makes it equal. So those are some things about the interval notation. All right, let's get down to business and let us work a couple problems, and then you can see exactly how that interval notation works when we have some solutions. And you can also see how similar this is to solving equations too. All right, problem I want to work on. It looks a little long, but it's not too bad. 10x plus 5 minus 7x is greater than or equal to 8 parentheses x plus 2 close parentheses plus 4. Okay, so this is the problem I want to work on. Looks a lot like our equations, except here, right here, you see a greater than or equals to. So you're looking for all the values of x that'll make the left side bigger than the right side, or the left side equal to the right side. Those are the values you're looking for, and there's going to be a lot of them. So that's why we're going to need the interval notation. But our quest to find the values will start out just like our quest to solve equations. We will simplify left side, simplify right side. All right, left side we got 10x minus 7x that can combine to 3x. Then we got that plus 5 greater than or equal to. Then right side we can distribute the 8. So we have 8x plus 16 plus 4. And then also can combine like terms. The 16 and 4 will combine, give us plus 20. All right, so I've simplified left, simplified right. Now I want to try to get x's together. I really like my x's on the left side. I mean, you can work it however you want. So if I'm going to go ahead and subtract 8x from both sides just to get my x's on the left. I like to do that with inequalities because it'll save me any confusion later about what symbol to use. So I've got negative 5x plus 5 is greater than or equal to 20. And then I'm going to subtract 5 from both sides. So I got negative 5x is greater than or equal to 15. Well, I still have to finish solving for x. I've got a negative 5 times x, so I'm going to divide both sides by negative 5. And that'll give me 1x on the left, and it'll give me negative 3 on the right. Now you might notice I didn't keep writing my inequality sign in the middle, because I want to point out right here, in order to finish, isolating the x, I ended up having to divide both sides of the inequality by a negative 5. If you have to multiply or divide both sides of the inequality by a negative number, the inequality sign has to flip. So it goes from greater than equal to less than or equal to. Okay, and in case you're kind of wondering why, here's a little sidebar. Let's say you have something like 7 is less than 10. That's true, right? 7 is less than 10. The mouth's open to the bigger one. The mouth's open to the 10. As soon as you take both sides and, like, let's say multiply them by negative 2. I'm just pulling negative 2 out of a hat, but I wanted a negative number. As soon as you do that, you can't leave the less than symbol there, because negative 14 is not less than negative 20. No, you have to flip it and now say greater than, because you got to keep it true. Right. We're keeping it real and we're keeping it true. So that's the story on the inequality flipping right here. So whether you're multiplying or dividing both sides by a negative, you're going to do that. Just adding or subtracting, you don't have to do that, because adding or subtracting doesn't affect the inequality. But multiplying or dividing by a negative will affect that inequality. All right, now, as I said too, solutions have to be put in interval notation. Our solution set is every number you can imagine for x, as long as it's less than negative 3 or equal to negative 3. So it can be negative 3 or it can be anything less than that. So you got negative 3, or anything less or to the left would carry you all the way out to negative infinity. If you think about a number line, you've got negative 3 right here, and then everything less than that is this direction, heading out towards negative infinity. So the smallest value we can put is negative infinity. It's not really a value, it's a concept, but still, we can put negative infinity, and then the largest it goes up to is negative 3. Infinities are never included. You can't touch them. You can't touch this. So you put parentheses around negative infinity. And then negative 3, since this is a less than or equal to, we get to use the bracket around negative 3 to say, hey, negative 3 is part of this club. It's part of this interval. It gets included. So there you go. So that is an example of solving a linear inequality in one variable. And I think I left some space here to do some more. I also need to show you guys the graphing concepts, but maybe I'll do one more of these analytically. Let's do one with some fractions. Let's see here. Let's do one where you end up with a positive infinity in it. All right, that looks like a good one. All right, x minus 2 over 2 minus x plus 6 over 3 is greater than negative 4. Okay, here's one that has fractions in it. I would like to eliminate fractions. So I'm going to look at the LCD here. Let's see, with 2 you got 2, 4, 6, 8. Who do we appreciate? 3 you got 3, 6. Oh, there you go. Right there, 6. So LCD is 6. So multiply the entire inequality by 6. And I don't need to do any sign flipping because 6 is positive. Multiplying both sides of the inequality by 6, keeping the greater than sign in there. Okay, so on the right, I've got greater, it's greater than negative 24. Now, if you multiply or divide by a positive number, you can leave it alone, leave the inequality sign the same. Okay, over here, I've got 6 times the x minus 2 over 2. 6 and 2 reduce to 3, so I got 3 times x minus 2 minus 6 times the x plus 6 over 3. 6 and 3 reduce, so I got minus 2 times x plus 6. Alright, distribute my 3. I got 3x minus 6. Distribute my minus 2. I got minus 2x minus 12. 3x minus 2x is x. Minus 6 minus 12 is minus 18. Add 18 to both sides. X is greater than negative 6. Okay, so on a number line, got negative 6 down here. And you got all the x's that are bigger than 6. So everything after 6 on to the right. So out here to positive infinity. So starting with negative 6, going all the way out to positive infinity. Infinities always have parentheses. And in this case, it's just all the x's greater than negative 6. So we don't want to actually include negative 6. We just want to include everything bigger than it. So we put parenthesis on negative 6 to say, hey, we're going to start right after negative 6 with like negative 5.9999999999999 and so on, but not negative 6. And then everything bigger up to just forever and ever, positive infinity. So there you have it. There's the solution for that one. Okay, I think I'm going to skip showing you a third example and go right into talking a little bit how to do the graphing. We did the graphing earlier with equations, and you guys saw the intersection of graphs method and you saw the x-intercept method. We can apply both of those methods here too with inequalities. Intersection of graphs method, graph left side, right side, see where they intersect. But since it's an inequality, you have to be careful how you interpret. The intersection will show you where they would equal each other. If you have a greater than or greater than equal to sign, you have to figure out where the left side is above the right side in the graph. If you have a less than or less than equal to sign, you got to figure out where the left side is below the right side in the graph. And then x-intercept method, you would still subtract left side minus right side, graph it, see where it crosses the x-axis, see where the 0 is. For greater than or greater than equal to, see where that graph is above the x-axis. For less than or less than equal to, see where that graph is below the x-axis. And go from there. Okay, so they didn't give us much space. So let's go back to this one. We already worked it, so let's look at it. But let's use graphing calculator. Okay, and in our graphing calculator, let's go ahead and put this left side in for y1. So 10x plus 5 minus 7x. And then let's put that right side in for y2. 8 parentheses x plus 2 plus 4. Okay, 8 parentheses x plus 2 close parentheses plus 4. Did I do it right? 8 parentheses? Yeah. Okay, so we hit graph. And we're going to see two lines that intersect each other. Now, I am going to quickly lose track of which line is which. So I'm going to go down and make the second line thicker, because that'll just help me visually to remember, oh, okay, that's y2. All right, so the thinner one's y1, thicker one's y2. I can do second trace to the calc menu and compute the intersection using number 5. Cursor's right here on this line, just hit enter. Cursor should have jumped to the other line, so hit enter. Enter to guess the intersection. X equals -3. Surprise, surprise. You know, right here we had x is less than or equal to -3. -3 is the place where it's equal. That's the point of the intersection. One of the things we want to do, though, is figure out where x is less than or equal to -3. Or in the original equation, where was 10x plus 5 minus 7x greater than or equal to 8 times x plus 2 plus 4? So since we put y1, y2 in, we got to think about greater than or equal to. So where is y1 greater than or equal to y2? Where is y1 above y2? Well, right here at the point of intersection is a switch. Right here at the point of intersection, the thicker one, y2, is higher than the thinner one, y1. But we want to see where the thinner one is higher than the thicker one. And that is right in here. Let me see if zooming out helps a little bit. Check it out, see what happens. I don't know if they're going to be too close to each other to see. Okay. So down here, and before you get to the intersection, the thinner one, the y1, is hanging out higher than or above the thicker one, y2. And that's what we want. So when you're thinking about the graphs here, oh, I can just go to ink color and not say pen. That works. Great. So when we're looking at the graphs there, you had y1 and you had y2. Just caution you, I'm just sketching this. This is not accurate, just to get the idea. So the point of intersection we know is at x equals -3. But when you're looking at your grid, when you're looking at your x values, for everything to the left of x equals -3, y1 is hanging out above y2. And that's true for until you go out to -infinity. So for everything from -infinity up to -3, y1, this side, is bigger or higher than y2, or this side. So the interval goes from -infinity to -3. Out here from -infinity up to that -3. And then since the question was greater than or equal to, we say, well, we're going to include the -3, so we're going to do a bracket. And that matches up with what we figured out when we did it analytically. Now, if they had had the question asking originally less than or equal to, then you're saying, well, where is y1 less than or equal to y2? Then you're saying, okay, let me see where y1's under y2. And that's over here. Over here, y1 is lower than y2. So from -3 is where it equals, from -3 out to infinity, starting here and going out to infinity, y1 was under or below y2, less than y2. Then it's equal at -3. Okay, and then the other method, let me just use the same graphs again. The other method was the x-intercept method. That's the one where we said, all right, let's do vars, y vars function y1 minus vars y vars function y2. And then let's go over and turn off y2 and y1. You'll go over, highlight the equal sign, and hit enter. That'll turn off those from being your graphs. Okay, I'm going to go ahead and zoom back in. I don't really like it being so thick right now. Ooh, that ended up not being the greatest. Let's go to zoom. And if we go ahead and do Z standard, it'll like standardize that window for us and center everything. Yay! All right, so with this method, I'm interested in seeing where does this line cross the x-axis. So let me go to second trace to calculate. Come on. Oh, it's still growing the graph, I guess. I wouldn't be surprised if it freezes up on me. It does seem to be freezing up. Okay, well, if that happens, try closing it. If that doesn't work, you can always try pausing the video and coming back in a few minutes, kiddos. All right, I'm going to pause. I'll be back. Okay, picking right back up. I had to take a little break. To you, it's probably going to seem like 2 seconds, but to me, it was several minutes. Anywho, I went back and had to shut down the calculator and do task manager and shut it down and then turn it back on because it was just completely frozen. And then hopefully I put everything back on correctly. Put the y1 back in, I put the y2 back in, and then y3 I have y1 minus y2. All right, so I go to graph, and I get to see that y1 minus y2 right here, that beautiful line. And I should be able to go to second trace and calculate the zero, number 2. The zero of a function will tell you where it crosses the x-axis. So left bound, let's see, scrolling, where am I? To the left. Okay, I need to make sure my cursor is to the left of where the line crosses the x-axis. Then for right bound, I gotta make sure my cursor is to the right of where the line crosses the x-axis. And then just hit enter for guess. And there you go. There is the zero of the function. So it's telling me that the line crosses the axis at -3, which I totally expected because when I solved the inequality, I'd gotten x less than or equal to -3. All right, so now we are trying to figure out, since the original problem has greater than or equal to, in that case, for this method, look at where is the line above the x-axis. If the original problem had had less than or equal to, you'd see, well, where's the line below the x-axis? So we're looking at where's the line above the x-axis. Well, it's above it all along here, and it goes up to infinity. So if you're looking at your x values, you're going to have x values way out here to the left from -infinity all the way up to the point that it crosses right there at -3. So that again confirms -infinity to -3. And including -3 because of the equals. So your graphs methods can be used here as well, besides the analytical methods. So that was the graphical interpretation of linear inequalities. All right, one more thing in this lesson. Let us quickly address three-part inequalities. And let's try to work on on one of those and then show you what they look like graphically. And that'll wrap up this section. All right, let me give you an example of a three-parter. Okay, let's say I have something like -3 is less than or equal to x minus 4 over -5, which is less than 4. Okay, a three-part inequality. What this is essentially the same thing as is saying that -3 is less than or equal to x minus 4 over -5, and x minus 4 over -5 is less than 4. So for those of you who are intermediate algebra veterans, you can remember that and means intersection. So essentially what you've got here are two inequalities, and that you're then trying to figure out, well, what's the intersection of their solutions? Where do they overlap? So you can always, you can always solve these two separately and see what you get. Or in this case, if the inequality signs are both pointing to the left, like this in the three-part inequality, then you can try to solve it all at once. Sometimes if x's are in the left and right, it doesn't work as well and it's easier to break it up. But in this one, all the way to the left here is just a -3, all the way there to the right there is 4. So I can go ahead and just tackle this all as one big piece. So what I'm going to do is I'm going to try to get x by itself here in the middle. So I'm going to multiply by -5, but I got to make sure I do that to all three parts. You can't just do it to one part. I got to keep it all balanced if I'm going to solve the whole thing in one fell swoop. So I've got -5 times -3 in this first part, which will give me 15. I've got -5 times x minus 4 over -5, which is just going to give me x minus 4. And then I got -5 times that 4, which is going to give me -20. Now I did multiply by a negative on all three parts, so I do have to flip my inequality signs. Then I'm going to add 4. So again, I'm still trying to get x's by themselves. But make sure I do it to all three parts. And now the x is all by its lonesome there in the middle. And that's what I wanted. Now I don't particularly like inequalities being written larger to smaller. I feel like it just works better if I write them smaller to larger. So I'm going to put the -16 over here and the 19 over there. And I can do that as long as I keep the signs pointing to the correct things. Between -16 and x, the mouth is open and ready to chomp the x. So down here, the mouth still needs to be open, ready to chomp the x. I don't want to change the meaning of it. Between the 19 and the x, the mouth's ready to open and chomp the 19. So I need to have that here too. Basically, I'm just doing a mirror image of what I had there, because I just feel more comfortable having negative to the left and positive to the right like that. Okay, so the solutions. If you're thinking about a number line, sorry for my curved number line there. Number line from -16 to 19 with 0 somewhere in there. Your solutions, x is bigger than -16. So you start heading out from -16 to the right, but it's also less than +19. So you got to stop at 19. -16 is just less than x, so -16 is not included. So you're going to do a parenthesis right there at -16. But 19, x is less than or equal to 19, so we're going to do a bracket there. So in interval notation, you got negative 16 comma 19, parenthesis on the negative 16, bracket on the 19. That's all the solutions to it. Then on your calculators, if you want to see how that works in the calculator, let's go show. Let me clear that out from the last example. All right, we're going to go ahead and put the 3 parts in. We're going to put negative 16 in for y1. We're going to put x minus 4 divided by negative 5 in for y2. And we're going to put 4 in for y3. So left side goes in for y1, middle part goes in for y2, right side goes in for y3. We hit graph. You're going to see 3 lines. Better see 3 lines. Why am I not seeing the 3rd line? Heck? Oh, I'm looking at one thing and saying another. I'm so sorry. That should be negative 3. There should be x minus 4 over negative 5, and there should be 4. I'm so sorry. I was looking down here at the answer. I needed to be typing this up. I don't know why that happened. So, all right, let's try this again. All right, I'm not seeing everywhere that things intersect, so I'm going to go ahead and zoom out a little bit. Hopefully this won't zoom me out too far. I have a feeling it will. Yeah, zoom me out too far. Well, let's zoom back in. Sorry. And then let's fix our window ourselves. I bet I just froze it up. Okay. It's frozen again. Yeah. Poor thing. All right. I'm going to pause you guys. I'll be back. Alrighty, I'm back. And the zooming's not working so great, so let's just adjust our window. I need to see where it intersects here and where it intersects over here. So I essentially need to see further left, further right. So let me go to window and let me change my x minimum to negative 15. My x maximum to positive 15, and let's see what that does. Because x min and x max will tell you like the smallest and largest x values that the calculator is displaying. Y min, y max will be, smallest and largest y values. And silly me, I can just look at my answer here. I know I need to go beyond that. So let's try negative 20 and 20. So let's go back to window. Let's do negative 20 to 20. See what we end up with. Okay. Intersections. Second, calculate intersection, number 5. Right now, the cursor's down here. I'm going to get over here closer to this intersection. Hit enter. Okay, cursor's on that line. Hit enter. It'll show me the intersection point there. Is at 19, which is exactly what I expected. And then I can do this again. This time, well, I don't really want it on this line, so I'm going to use my up or down arrows to switch from line to line. Left and right moves it left and right. Up and down, I'll switch it from graph to graph. And I want to find this intersection over here. Did not go on the one I wanted it to. There we go. And then enter. So that's at negative 16. Exactly what I expected, because I know that my endpoints are negative 16 and 19. The x minus 4 over negative 5, that's this line. And I'm just trying to see, well, where is it sandwiched between the negative 3 and the 4? The negative 3 is this line, the 4 is that line. It's sandwiched in between from negative 16 to 19. So if I draw this graph sorry, keep taking it for granted that it's going to already be working as a pointer. It's not. All right, so I've got two lines that are parallel. This is the y equals 9, or y equals 4. And then I got one down here. That's the y equals -3. And then this transversal is y equals x minus 4 over -5. I've determined that the point of intersection there is at x equals -16. And the point of intersection there is at x equals +19, which just is confirmed by the solution I got earlier when I worked this out analytically. Now I'm trying to see where this x minus 4 over -5 is sandwiched between -3 and 4. And that occurs right here, in between -16 and 19. So in between -16 and 19, and then since it's less than or equal to for the where it intersects y equals -3, then the 19 gets the bracket, and since it's less than for where it intersects the y equals 4, then that's -16 is going to get a parenthesis. So the graph shows us the same result. And there you have it, 3-part inequalities. So there you go. Enjoy. Next time you tune in, we will be doing some application problems that relate to all this linear equations and linear inequalities that we've been solving. See you until then. Have fun.